All right, so this is extra practice with triangles for Unit 3. There's some common mistakes you guys make with dealing with the sides of a triangle and the angles of a triangle. And so we need some extra practice to make sure we get what we're supposed to get down. So in number 1, it says if 3 sides of an equilateral triangle measure, and there's a key word in there, and that word was equilateral. And remember that equilateral triangles has 3 congruent sides, which then implies 3 congruent angles. Okay, so we can go ahead and draw a triangle. And before we do anything with those expressions, I'm going to go ahead and get those 3 equal sides and the 3 equal angles. And if you guys remember from our notes, in a triangle where there's 3 equal angles, all you have to do is take 180 degrees for the triangle sum and divide it by 3, and each angle will come out to be 60 degrees each. Equilaterals, triangles, angles can never change. Okay? So he's easy. All right, so going back to the sides, it says the 3 sides. So make sure that we label the sides on the outside of the triangle. So one will be 5x, one will be 2x plus 9, and the third one will be 6x minus 3. Okay, and they want to know what is the measure of one side. So we have to be able to solve for x, and then we can plug in. And when we plug in our value of x, they all should come out to be the same. If they don't, we did something wrong, and we have to go back and fix it. Okay, and so because any 2 sides are equal, you can't set all 3 sides equal. You could set these 2 equal to each other because they are indicated by the tick marks. Okay. You can set 5x equal to 6x minus 3 because those 2 sides are equal, indicated by the tick marks. Or you could set 2x plus 9 equal to 6x minus 3 because they're equal, indicated by the tick marks. You just can't set all 3 equal because you have 2 equal signs and an equation can only have 1. So it'd be weird. So you pick whichever 2 expressions you want to set equal is the 2 that we're going to set equal. So I'm going to pick 5x, and I'm going to set it equal to 2x plus 9. Just because I'm doing this setup doesn't mean that you don't have to, you can, you can't do another one. You can. You could pick any 2 sides and set them equal. It does not have to be these 2. Okay. And I'm going to go ahead and solve for x. And x comes out to equal 3. However, we didn't answer the question. They want to know the measure of one side. We're going to go ahead and I'm going to show you how by plugging in 3 to all the sides, they're all going to come out equal. So on this one, this is 5 times 3, which is 15. 2 times 3 is 6. 6 plus 9 is also 15. And on the bottom here, 6 times 3 is 18. And 18 minus 3 is, you guessed it, 15. And so all 3 sides end up being 15. And so we can go ahead and say one side equals 15. If they asked me for the perimeter, which they didn't, but I could, perimeter is the sum of all sides. So if I added up 15 plus 15 plus 15, the perimeter would be 45. Not that they asked for it, but just in case, another question might. Okay. All right, going down to number 2. It says that the perimeter of triangle red. So I'm going to go ahead and draw a triangle. And of course, I'm going to go ahead and draw it in red. Is 73. So we have to remember that their perimeter is 73. So see, I told you they were going to talk about perimeter. And then it says that angle E is congruent to angle D. And a lot of people will read right over that, and you can't. That is going to be super important information that tells us how we set up this problem, and it will help us out in the long run. So again, equal angles get arc marks. So we're going to go ahead and arc mark angle E and arc mark angle D. And as soon as you put 2 arc marks or 2 equal angles in a picture, you're going to go ahead, and they're not going to tell you to do this. You have to know to do it, but you're going to go ahead and go across and mark the 2 equal sides. So go across from the 2 equal angles and mark the sides that are across from them. Okay. If a triangle has 2 equal angles, it automatically has 2 equal sides, and that's going to help us. Okay. What they say next is that RE is 2x plus 3, and that ED is 4x minus 13. And and they want you to find the value of each side. So remember, they told you the perimeter is 73, and so we're going to add up all the sides to equal 73, except we're missing a side. However, we were smart enough to mark the two equal angles that they told us and then mark the two equal sides. And because this side called RD doesn't have an expression, but we know that it's equal to RE's side, we're going to go ahead and borrow RE's expression and put 2x plus 3 here. And now we could go ahead and add up our one side plus the side that's equal to it. So we got another 2x plus 3 plus our third side. And we are going to go ahead and set that equal to the perimeter, which is 73. Now, some people might be thinking, why aren't you adding them up to the equal 180? I thought triangle sum was 180. Okay, so this is what we call a side party. Remember when you use 180, that 180 is measured in degrees. Only angles are measured in degrees, and these are not representing angles, they're representing sides. So I call this a side party. And if this is a side party, sides never invite 180 degrees to their party because that's for angles. So you can only invite it to an angle party when you have all three. All right, so we'll combine our x's, 4, 5, 6, 7, 8, 8x. Positive 3, minus 13 is negative 7, equal to our perimeter of 73. Go ahead and add 7. And we get 8x equal to 80. Divide by 8, and x comes out to equal 10. However, we didn't answer the question. They said find the value of each side. So I got to go back now and plug in. So 2 times 10 is 20. 20 plus 3 is 23. This is also going to be 23. And 4 times 10 is 40. 40 minus 13 is going to be 27. And so we'll just keep a running total over here of our sides. But RE is 23. RD is 23. And ED is 27. Okay. Then part B says classify the triangle by its sides. Well, remember sides. S for sides, S for scalene, isosceles, or equilateral. And because this has two equal sides, we are going to go ahead and call this triangle isosceles. Just like you have two equal eyes on your face, isosceles. Okay? All right, number 3. In number 3, it says that we have a triangle ABC. And it tells us that the measure of angle A is x plus 30. And remember, angles get labeled inside the diagram. Angle B is 4x. And angle C is 3x minus 10. And because these are angles, and I have all three of them, we're going to go ahead and say that this is an angle party. And we're going to go ahead and invite 180 degrees to it. So we're going to take our three angles. We're going to add them all together. And that sum should equal 180 degrees. So we have 4x plus 3x, which is a grand total of 8x. We have a positive 30 minus 10, which is positive 20, equal to 180 degrees. We're going to go ahead and subtract 20. And we end up with 8x is equal to 160. And we're going to divide by 8. And x will come out to equal 20. Okay, and that's all part A wanted to know, was find the value of x. So that one's finished. Okay. However, part B says classify the triangle by its sides and angles, and we wouldn't be able to do that unless we know the measures of the angles. So we're going to have to plug in, even though they don't say to plug in. And in angle A is 20 plus 30, which is 50 degrees. Angle B is 4 times 20, which is 80 degrees. And angle C would be 3 times 20, which is 60, and 60 minus 10 is 50. And based on those angles, if we have to classify it by its sides, like we did in the last one, remember S for sides, S for scalene, isosceles, and equilateral. There are two angles equal, just like in the last picture. Therefore, there will be two sides equal. In fact, if I go back to my picture, since these are the two equal angles of 50, these would be the two equal sides, okay? And therefore, he would be known as isosceles. Based on the angles, you have to recognize A for angles, A for acute, right, or obtuse. Because all three angles are acute angles, then this would be called an acute triangle. So this is an acute isosceles triangle. Okay. All right, number 4. In number 4, we have another triangle called ABC. And in this triangle, angle A is x squared plus 65. Angle B is 5x plus 2. And again, these are angles, so that's why they're going inside the diagram. Angle C is 10x plus 13. And they want you to find the value of x. Well, this is an angle party again. We have all three angles inside the triangle, and so we're going to go ahead and invite 180 to our party. So I'm going to take all three angles and add them together. And equal it to 180 degrees. You might notice that we have a square term, which makes this problem a little bit more difficult to solve than the one above it. But I'm going to go ahead and combine my like terms. So x squared stays, nobody like him, no other square terms. We have a 5x and a 10x, which is 15x. And then I have a 65 plus 2 plus 13, which is a grand total of positive 80, equal to 180 degrees. So you notice I did not do what I was supposed to yet. And what that was is that, remember, a square term tells you two answers. Two answers tell you that you have to factor to get them, and you can't factor unless you're equal to 0. So I did not get equal to 0 yet, but I am going to go ahead and now that that left-hand side is cleaned up, I'm going to bring this over. And I'm going to end up with x squared plus 15x. 80 minus 180 is negative 100. And we are equal to 0. I'm going to go ahead and set up my x box for my easy trinomial. Remember that the multiply number is at the top, which is the last number, which is negative 100, and the add number is at the bottom, which is positive 15. And you can use your table to scroll through some numbers, and hopefully you will find the two numbers that do the job. Okay, 1 and 100, too far apart to give you a 15. 2 and 50 are too far apart. They might give you a 48, but not a 15. 4 and 25 are getting closer, but they would have like a 21, not a 15. And hopefully, eventually, you see 20 and 5. And to get a positive 15 out of 20 and 5, we're going to make the 5 negative, which then if we check to see if they multiply to negative 100, it does. And if they add to 15, it does also. And so we're going to use those numbers. Remember, this is what I call an easy trinomial. It's easy because you can go right to the factors. You break up that x squared term into x and x. One gets a positive 20 and the other one gets a minus 5. And now that I have my two factors, I set each factor equal to 0 and I create two mini equations. Each equation is going to give me an answer. On this side, I'm going to go ahead and subtract 20 and I end up with x equals negative 20. On the other side, I'm going to go ahead and add 5. And when I'm done adding 5, I get x equals positive 5. And this is where algebra and geometry are going to butt some heads because we can't have two answers, especially when there's a picture of angle. Okay. And so I'm going to assume that our answer of negative 20 is not going to check out. And you can see that right at the top angle of angle B. So if I do 5 times negative 20, that's negative 100 plus 2. Negative 100 plus 2 is negative 98. And I can't have an angle, especially negative, inside of a triangle. And so we're going to go ahead and say this is going to reject. Okay? And then we're going to go ahead and keep our answer of x equals 5. And that's all part A wanted to know. Okay? However, part B says to classify the triangle by its sides and angles like the last question did. And so we're going to have to plug in even though they don't tell us to. So up at let's go in alphabetical order, I guess. We'll go with angle A first. 5 squared is 25. And 25 plus 65 makes angle A 90 degrees. Angle B is 5 times 5, which is 25, plus 2, which is 27. And angle C is 10 times 5, which is 50. And 50 plus 13 makes this angle 63 degrees. And so now we can go ahead and say, all right, based on its sides, remember S for sides, S for scalene, isosceles, and equilateral. I would say equilateral, all three angles would be equal. Isosceles, two angles would be equal. And therefore, this is no angles equal, no sides equal. This is known as scalene. Okay, based on its angles. A for angles, A for acute, which two of them are. Right, which I do have a right angle of 90 degrees, or obtuse, which is an angle over 90, less than 180. And because I have this nice right angle at angle A, I'm going to go ahead and say that this is a right triangle. So we have a scalene right triangle. Okay. All right, guys. Hopefully that is a little bit better. When to use 180 when you have angles, when not to use 180 when you have sides. Okay. And we got a couple more problems on the back, so I will see you guys there.